Hey guys, it's Teddy here, and today we will be solving the problem. Check if a word occurs as a prefix of any word in a sentence. Now, what does this question exactly say? It says that we'll be given a search word and we'll be given with a sentence. Now, for the search word we are provided, we need to check if that search word exists as a prefix in any of the word in the sentence provided. What is a prefix? A prefix is a part of the word that appears at the beginning of the word, right? So, let us look at the first example here. We are given with the search word B-U-R-G, burg. Now, in this sentence, I love eating burger. We can see that at the fourth word, the prefix B-U-R-G is present. In the second example, pro. Pro is present in the sentence two times, in the word number 2 and in the word number 6. Now, in this case, we need to return the first occurrence of the search word, right? So the first occurrence of the word pro is in the word number 2. So in this case, the output is 2. Now, if the search word does not exist as a prefix in the sentence, for example, then in that case, we need to return -1. So this is what the question is all about. Now, one thing you need to keep in mind is, if suppose the search word exists but it is not a prefix, in that case we also need to return -1. Now, what do you mean by that? Let me give you an example. Let's suppose I consider a sentence, I have products. Okay, now the search word is, say for example, duct. We can see that in the word product, the substring, let us say it's ducts, the substring ducts occur, but still in this case we need to return -1 because ducts is not a prefix of the word product. So I think you have understood the question as a whole. So let me just quickly erase this and we will understand how to solve this problem. Now, the basic naive solution that can come to your mind, that is the brute force solution, is something like this. In this example, we were searching for the prefix burg in every word, right? So I does not contain burg, love does not contain burg, eating does not contain burg, burger contain burgs, right? So what we can do basically is, why not check for the prefix in every word, right? So what we can basically do is separate out every words from the sentence. So given the search word, we can compare burg with I, burg with the second word love, with the third word eating, and the fourth word burger, right? That is what we need to do basically. So this is the basic naive approach that can come to anyone's mind. So how can we code this up? It's quite simple. Let's firstly try to separate out each words. So let us store each of the words in a vector. So maybe the position 0 will contain the string I, 1, 2, 3, and so on. So how do we do that? Let us declare a vector of type string, and let's name it words. So now for a sentence, we need to push every word within the string. Now, how do we separate words from a string, right? So if you quickly look at the example here, each word is separated by a space character, right? For example, 0, at the position 1 there's a space, at the position 6 there's a space. So we know for sure that every word is separated by a space. So it becomes fairly simple to separate out each word. So what we can basically do is, we can just iterate through the entire string. So something like this. What I'm considering n here is the length of the sentence. So if we encounter a space, we know that's the end of a word. So maybe there's a string named word. So if we encounter a space, what we can do is basically push the word. All good? And else. What we are doing is, in this variable word, we are storing the current word. So when we are iterating through the sentence, for example, love burger, at position 0, we'll add this to this, add the letter L to the word, then we'll add the letter O, then we'll add the letter V, then we'll add the letter E, one step at a time when we are iterating through the sentence. So elsewise, we are just adding the current letter to the variable word. So plus equal to sentence of I. Now consider within this if block, after pushing the word, we need to reset the word to an empty string, because otherwise, if word currently has love and then we again push B, it will be something like love space B. We don't want that. We want a fresh new word within the variable word. So in this if block, we also need to change word to an empty string after it is pushed into the vector. So this is how you will be pushing each of the words, that is separating out each of the words to the vector. Now once this is done, what we can do is start comparing. So let me quickly erase this. Okay, let's get started. So after we are done pushing each word within the vector, what we need to do? Firstly, look here. When we encounter the last space, we push the word eating, but we also need to push the word burger, because as we can see at the end of the sentence, there's no space. So firstly, what we need to do is push the last word to the vector. So words dot push back word. Now observe. Now we will be taking out each of the word one by one and comparing it with the word given, the search word given. So how do we take out each word at a time? Something like this for string on words. This will take out each of the word within the vector. So now we need to start comparing with the search word. So one thing I know for sure is, if the length of the search word matches with the length of the search elements, we know for sure it's a match. So in order to store how many characters have matched till now, I'll be considering a variable named match. Next step, we'll iterate through each elements of the word. So what do we mean by that? For example, burger and burg. So we need to compare the first two elements, then the second two elements, then the third, then the fourth. So we need a loop for that, right? To compare each and every position. So I'll be taking a loop. Now we know that loop will run till the maximum length of the search word, because that's what we need to check. So maybe something like j equal to 0, j less than s dot length j plus plus. So now what we will do is basically compare each of the characters from the word and the search word. So if s of j does not match with the search word of j, that is, let us consider in this case I and burg, this and this does not match. So what in this case we'll do, we'll simply move on to the next word, that is, we need to break from this loop. So we'll just break. Elsewise, let's suppose it's matching burg, gur and burg, so B is matching. Elsewise, we'll just increment the length of match. Done. Now if at any point the length of match is becoming equal to the length of the search word, we know that each and every character has matched. So in that case, we just need to return the position of the word, right? So we have not kept track of the current word which we are in, so for that we can just take a variable and position equal to 1. Why 1? Because we are starting from the first word. See, this is at index 0 but the word number is 1, so int position equal to 1. So in this case, if there's a match of the length of the matching characters and the search word, we can just return the position of the word, so return position, that is if it is the first, second or the third word. Elsewise, after we are done with this loop, if the current word does not match with the search word, so we just move on to the next word, that is we also say that the position of the word has changed. We are currently at the second or maybe say third word, so position plus plus. Now if it does not match at all, what we need to do is just return -1. That is what the question asks. So this is basically how we'll be coding this up. This is the entire code, and to demonstrate, let me just quickly code this up. So it will be something like this. We'll be considering a vector of the type string to store each and every word, so vector string words, and then we'll store the current word within a string called current word, and also we need the position, so int position equal to 1. So now what we are doing initially is store each of the words, separate out each of the word to store it in the vector words. So for int I equals 0, I less than sentence dot length I plus plus. So if sentence of I equal space, that is if we encounter a space, what we will do is just push the current word, so words dot push back current word, and also we need to reset the current word to an empty string, and elsewise we just need to add the present character to the current word. After we are done with this, we will be storing up to the second last word. To store the last word, we need to again push back the current word, because at the end of the string, if it does not encounter a space, it won't push the last word. So till now we have separated out each of these words. So now we need to compare each of the words with the search words. So for that, now consider a variable match. S of j not equals to search word of j. What we'll do in this case, we'll just simply break out of the loop because there are no matching characters. Elsewise, what we'll do is increase the value of match because we are getting more matching characters. Now if any point the match length becomes equals to the length of the search word, we know at this position the word is present, so we will not just return the position of the word. Elsewise, we will just move to the position of the next word, so position plus plus, and if we do not get any matching words, we just return -1. So this is the entire code. It should run fine. Let me just quickly go ahead and submit this. Oh, there's a slight error here. We need to just modify it to j++, and rest everything should be perfectly well and good. Yeah, and it's getting accepted. So this was the brute force attempt. Now we'll move on to an optimal solution, because here we are using an extra space and we need to optimize this extra space we are using. So let's just go ahead and optimize it somehow. Now in this optimized approach, what we'll be doing is basically using the concept of 2 pointers. So what do we mean by 2 pointers? Firstly, we'll be iterating through the entire string, that is the entire sentence, just once, and we'll be keeping a pointer, that is we'll be basically keeping track of the indexes. Let us consider this example. I love eating burger, and the search word given to us is burg. So we'll keep 2 pointers. So the first pointer will be at the position 0 of the sentence, and the second pointer will be at the position 0 of the search word. Now compare each of these elements. So I and B does not match, move ahead. Space, move ahead. L, B does not match, move ahead. O, V, E does not match, so we'll move ahead, and we will keep on moving ahead unless we encounter a matching element. So at this position we encounter a matching element B. So what we need to do now is move both of them ahead. Move this ahead here and move this ahead here. U, both of them matches. Again move both of them ahead. Matches, move both of them ahead. Matches. So if we get a match, we move both of the pointers ahead, and if we do not get a match, we move only one of the pointer ahead, right? Now also we need to keep a track of one thing, that something we need to consider is we need to look for a match only from the beginning of the first word, only from the beginning of the word. That is, if I give you something like hello and the search word is something like LLO, so in this case, if the first element of a word does not match with the first element of the search word, we need not check the rest of the portion of this word. So that is one thing which you need to keep in mind. So let us quickly code this up too. Now how do we exactly code this up, because how do we know if the first element does not match, then we completely neglect the word. So for that we might keep a track using a flag variable. That is, if the flag at any time becomes 1, so we know that we need to ignore the entire word because the first element is not matching. So in this case, maybe we'll firstly consider the position of the current word, so it will be 1, so current word will be 1, and we needed 2 pointers, right? So maybe I'll keep the track of the elements in the search word with a pointer j, and for this sentence we will iterate through the entire sentence, so we will just be using a loop, and that variable within the loop will be acting as a pointer for this sentence. So current word equal to 1, j equal to 0, and we need a flag. So if flag is 0, that means it's matching. So go ahead, move both of them ahead. So let us continue and write the pseudocode for this. So we need to iterate through the entire string. So int I equal to 0, I less than n, I plus plus. Now if both of them match, and only the first element, firstly we need to check if the first element matches. How do we know that? If flag is 0. So if flag equal to 0, and let's say search word of j is equals to the current element of this sentence, so sentence of I, what were we doing in this case? We were moving the pointer, both of the pointer, so j plus plus, and we need not write I plus plus because that will be done by the loop itself. However, another case, if we encounter a space, in this case we know that we are at a new word. So for this new word, again we need to compare the first elements, right? So in this case, again we need to set flag equal to 0 and j equal to 0, because say for example in this case product and proc is the search word and product is the word. In this case the first 3 letters are matching, so when j will come at this point and I will be at D, these are not matching, so again we need to reset j to the first position, so again we need to reset j to P. So in that case we also need to set j to 0, and also we are at a new word here, so current word plus plus, that is the position will get updated. Else what we can do is flag equal to 1, j equal to 0. Now after this is done, if we know j is equal to the search word dot size, we can just return how many words have we currently gone through and at which word we presently are. So return current word, and if none of the things matches, we'll return -1. So this is the entire code. Let us quickly code this up in LeetCode and see if the solution works. So let us quickly code this up. So iterating through the entire sentence. Now if flag equal 0 and search word of j equal sentence of I, what were we doing in that case? We were increasing j. Else if we encounter a space, what were we doing in that case? We were just resetting flag to 0 firstly, and current word ++ and j equals 0. Elsewise just set flag equal to 1, j equals 0, because we are not getting any match. So if at any point j is equal to search word dot size, return current word, and if none of the things matches, return -1. Should work perfectly fine. Let me just run and submit this to check for any errors. Yeah, and everything's working perfectly fine. So this is how you basically solve the problem, and thanks for watching.